In Chapter 6 of Volume 1, we go over factoring. In this section, we will cover common factors, factoring a trinomial, factoring by grouping, and special factoring formula. Down here in the scratch pad, we look at two areas where we use factoring. If we have a rational expression and we want to reduce it, we need to factor the numerator to reduce the expression. If we have a polynomial that's degree 2 or higher, we will factor the polynomial and set each part equal to 0 to get the answer. So these are two of the areas where we will use factoring. Now on our calculator, as you can see, it can reduce it automatically and it can solve for them automatically without the need for factoring. The first thing we're going to look at is determining when factors, what we try to factor, whether they're prime or irreducible. So when we take a look at some polynomials, they cannot be reduced, okay, and they are considered prime or irreducible. Let's flip over to the next page. So we're taking a look at the expression x squared minus 3 and then factoring it, and it gives us back x squared minus 3. So that means that over the integers that this particular one is irreducible. If we're factoring over the rational numbers, we can get fractions involved in our answer. So we can change this to multiply by 4 over 4. Then when we have x squared minus 4, it factors into x minus 2 times x plus 2, and the whole thing will be over 4. So it's a little tricky to do factoring when we're doing it over the rationals. The opposite of factoring is where we multiply things together. Remember in the last unit we used expand. Well, sometimes expand is not necessary. So if we have something with square root in it, we can multiply back here and get x squared minus 3. So if we're talking about the real numbers, this will factor into these two parts, but as you notice, our calculator will not do that for us. But it will do the opposite. It will take the two and multiply them back together to get the original. Let's turn to the next page. And in the next page, you see we actually work out what we just said about that this factors into x minus the square root of 3 and x plus the square root of 3 over the reals and over the rationals by putting 4 over 4 and then factoring out the 1/4. This factors into x minus 2 over x plus 2. When we start factoring, the first thing we want to do is to pull out the greatest common factor. So if we flip over here and take a look at example 1 and have 3x squared minus 6, we can write the 6 as 3 times 2, then 3 is common to both, so we can pull it out to the front and get 3 times x squared minus 2. If we have an expression here with a negative involved in the problem, we will want to factor out the -1 to make the leading coefficient inside here be positive. So when we factor out a -1, this becomes positive, this becomes minus, and this becomes positive. Then after we factor out the -1, we can look at the inside and we can see that 3x is in each part. So since this is a cubic, it's going to need x squared. This is going to need 3x, and this is going to need 6. We've already taken the 1 out, so now when we take the 3x out, we end up with this answer. An easier way to think about factoring out the GCF, rather than write it in each part, is to put the GCF out at the front and think what goes in the blank to turn up with this answer. So that's what we're going to take a look at next. On our calculator, we have loaded this problem in. Notice that it's the CAS calculator because we can only factor expressions on the CAS calculator. So let me turn the page, and when you turn the page, you see over here that when we factor 3x squared minus 6, it factors out the 3, and when we factor this one, it factors out the minus 3x. Let's go ahead and take a look at this blank technique. So exercise 1 asks us to factor minus 4x minus 12 and 8x cubed y minus 16x squared y squared. So let's click on this link. Okay, here we show that we can pull out the minus 4. So we say minus 4 times what is going to give us minus 4x plus 12. So this is going to have to be the x to get the minus 4x, and this is going to have to be the positive 3. Then looking at this one, we can see that 8 goes into both. We can see that the lowest power of the x squared, of the x component, is equal to x squared, and the lowest power of the y and y squared is y. So again, putting this out to the front and then saying to ourselves, what do we need to fill in this blank to get this particular answer? So we can see that we're missing an x for the first term, and we can see that for the second part, we're missing a minus 2y. So we find this method easier to look at this blank and see what part we need to add. Let's go ahead and take a look at this on the scratchpad screen, what's going on in the iPad. So let's take a look at factoring. So we'll go over to our calculator. We'll press the scratchpad. We'll go to menu. We'll go to algebra, and we'll go to the factoring option. Then we'll put in, okay, negative 4x subtract 12. Press enter, and we see we get the same answers we get on our iPad program. Let's go ahead and do the next one. So we'll press menu, press algebra, press factor, type in 8, then x, then cube this, so we'll raise it to the third power. We'll move down, then it's times y. Let's go ahead and put in the times sign, because when you start dealing with two letters, if they're right next to each other and you don't have an exponent involved, you'll get the wrong answer because they'll think it as one variable. So it's probably not a bad idea to put in the times sign when you work on these kind of problems. Then subtract 16 x, then square it, times, and then y, and square it, and then press enter, and we get this answer, 8x squared times x minus 2y times y. So you notice that our calculator has a tendency to put things in here in decreasing power, and instead of putting the y up front, it used the commutative property to turn this terms and this factor around, but it's mathematically equivalent. Again, when we're writing this out, we would want to write this out with the y in the front instead of the way that our calculator does it. Okay, let's return to where we were. So the next thing we're going to do is come up with factoring trinomials. What we're going to do with a trinomial, one that has three parts, we're going to use the AC test. Okay, we're going to take the absolute value of A times the absolute value of C, and we're going to make sure that our A is greater than 0. So when we have a problem with a negative involved in the problem, we're going to factor out the negative before we do this. Then we're going to list the positive pairs of factors of the product of the absolute value of A times C. We're going to take a look if C is positive, and we're going to take a look if C is negative. So if C is positive, we're going to add the pairs. If C is negative, we're going to subtract the pairs. Then what we're going to do with the pairs, we're going to take a look at B. If B is positive, we're going to add each factor of the pairs. If b is negative, each factor of the pairs is negative. Each factor of the pairs up here is positive, I should have said. Okay, when we go down to this case where c is negative and we take a look at b is positive, then the largest is going to be positive, the smallest is going to be negative. If b is negative, the largest is going to be negative and the smallest is going to be positive. Now there's going to be two situations for this a. There's going to be the situation where a is equal to 1, and it is going to be the situation where a is greater than 1. If a is equal to 1, then these numbers that we came up with in here will turn out to be the factors. If a is greater than 1, we will change the middle term by regrouping it and then factor by grouping. Let's turn to the next page and take a look at the case where a is equal to 1. So we're going to take a look at x squared plus 6x plus 8, and we're going to take a look at where we have minus 3 times x squared plus 4x minus 12. Let's go back to part A. So by taking 1 times 8, because this is understood to be a 1, we get 8. Then we list all the positive pairs that make up 8. So this is 1 and 8, 2 and 4. Next, we're going to look at the C. Right here says that we add 8. So we consider this to be greater than 0. Then we look at the B, which is positive 6. So the B is greater than 0. So we're going to want to add these together. 1 and 8 make 9, and 2 and 4 make 6. Well, we see that we have the 6 here, so we're going to want to use 2 and 4, and when the front is a 1, we said that these are our factors, so this is x plus 2 and x plus 4. And we can check this by the FOIL technique. X times x is x squared, 2 times x is 2x, okay, 4 times x is 4x, add those two together, get 6, take the 2 and 4 and go together and get 8. I probably should have went in the normal order where we take the x times x and get x squared, the x times 4 and get 4x, the 2 times x and get 2x, and the 2 times 4. I kind of went in a different order when I did this. Okay, to work one out like this, we always want to get this into descending order, and we always want to get the coefficient to be positive. So what we're going to do here is we're going to factor out a negative 3. So when we factor out a negative 3, we're going to end up with x squared, we're going to end up with 4x, and we're going to end up with negative 12. Then we just ignore this negative 3 till we get down to the end. We take 1 times the absolute value of negative 12, which is 12. The pairs that make up 12 are 1 and 12, 2 and 6, and 3 and 4. Again, we're just looking at this part. So since c is less than 0, we're going to subtract the smaller from the larger. So 12 from 1 gives me 11, 6 from 2 gives me 4, and 4 from 3 gives me 1. Then we look at the middle, and we see that the middle is equal to 4. So since the middle is equal to 4, the factors are going to turn out to be these same signs, x plus 6 and x minus 2, and then we put back in the minus 3. Okay, so again, if you multiply this out by the FOIL technique, okay, you got x squared minus 2x plus 6x, so those two are going to combine to be 4x, and positive 6 times negative 2 is minus 12. And if we go over to our calculator, we can take a look at the same thing. So let's go back to our document. Let's go back to our home screen. Let's go back to our current document, which is number 4. Okay, this is example 2. So let's go to the next tab. And in example 2, we have this problem. So we factor, and we end up with x plus 2 times x plus 4. And we factor, and it pulls out the negative 3. I wrote these two in a different order, but because of our properties for factors, it doesn't matter which order that we write these two. So they have x minus 2 times x plus 6 when the calculator did it. Let's turn the page, look at what's going on next. So here we have the screen that we just got done talking about on our calculator, showing what happens, how we get the same answer. When you get to calculus, you have to deal a lot of times with fractional exponents. So let's take a look at this particular problem. And what you want to do when we're factoring out is you always want to factor out the smallest exponent. So when you're dealing with negative numbers, they're smaller than positive numbers. So we want to factor out, okay, x to the minus 1/3. So this is a little tricky, and it's explained down here, the details about factoring out. So again, look at your ebook and read these details out. When you get done doing these details, you will end up with the x to the minus 1/3 being out front. You will end up with x squared minus 16x plus 48 in the inside. Then we'll take the absolute value of 1 and 48 and get 48. Make up all the pairs that make 48, going from smallest to largest. 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Since the last one is positive, okay, in here c is greater than 0, we'll want to add these pairs together. So the first pair will make 49, the second pair will make 26, the next pair will make 16, and the next pair will make 14. So since the number in the middle is 16, but the number in the middle is negative, so when b is less than 0, you'll want these both to be negative, so it'll be x minus 4 times x minus 12 with the x minus 1/3 out to the front. Let's turn the page and take a look at this on our calculator. So we put in x to the 5/3 minus 16 x to the 2/3 plus 48 x to the minus 1/3. So we use our fraction template for the exponent. When we tell it to do this, it gives us x minus 12 times x minus 4. So what happened here was that when it factored out the x to the negative 1/3 in the front, the calculator doesn't like to leave negative exponents in the front, so it moved the negative exponent down to the denominator. So again, when you start using your calculator to help you with some of these problems, you're going to have to be comfortable with moving things around. And again, as we keep going further in this class and in more advanced classes, half our trouble will be taking answers that we work manually or work on our calculator and switch them to a slightly different form of the same answer. So again, we'll have to work on those kind of techniques. Here again, we're going to take a look at some messy types of problems that we have to factor. So we have x to the 1/3 and 4 plus x to the minus 2/3. So again, there are various techniques and stuff for working these things out. We know that we're going to want to factor out the smallest exponent. So the smallest exponent is going to be the negative 2/3. But another problem comes in here is because we have a fraction in the front. So if we multiply the first term by 1 and let it be 3/3, then we can factor out the 1/3. So when we factor out this minus 2/3 and we factor out this 1/3, we're left with 3 times 4 plus x to the first. Again, down here we explain these exponents. And when we factor out the negative 2/3, we're left with plus x. And then once we're inside the parentheses here, okay, we have 12 plus 3x plus x, so this becomes 12 plus 4x here. And then the 12 and the 4, okay, have a 4 that we can factor out, so this becomes 4/3 times 4 plus x to the minus 2/3 over 3 plus x. Let's go ahead and take a look at this one on our calculator because it's quite messy, and it's likely that the calculator is also going to turn out to have a messy answer. So let's go to our scratch pad. Let's clear out our scratch pad. Menu, 1, 5. Then we want to, factor this expression. So we're going to put in menu, algebra, factor. We're going to put in the first expression, the first term. So we're going to need a parentheses for add x. Then we're going to want to raise this to the 1/3 power. So we'll go ahead and hit our caret. We'll go ahead and use the fraction template and raise this to the 1/3 power. Then we'll move over. We need to write our second term. So we're going to put in plus. Then we need the fraction template. 1, go down here, 3, move over. Go ahead and put our times in. Then put in parentheses for add x. Close our parentheses. Raise this to a power. It's a fractional minus 2/3, so let's go ahead and use our fraction template. Put in the -2, go down, put in the 3, and then this is, times x, so we're going to have to move down here, put in our times, then put in our x, and hopefully we got everything in there right. Then we're going to press enter, and it gives us this answer here. Looking at this answer and looking at this answer, we notice that everything here is a factor, but over here we have the numerator written with terms. So if we want to switch from terms to factors, and we want to combine this stuff, we can use the common denominator operation. So let's go to menu. And we can go to number or algebra. Let's go to algebra. Let's go to our fraction tools, and notice that number 4 is common denominator. We want to put this whole part in here, so the easiest way to do that is to move up and highlight it, then press enter to copy it down inside our common denominator operation, and then press enter. So after we do this, we get an answer that looks a lot more like our answer over here. So what happens is the part here still has the 4x plus 12. Where this step it had the 4x plus 12 written in a slightly different order. The negative exponent, was taken down to the denominator along with the 3. So we could try one more thing to get our answer to look like this answer. So if we go, because we could factor these two, so if we go to menu, we go to algebra, we go to factor, we go up to here, we press enter, and then to bring it down, and then press enter. We get our answer with this negative exponent written in the bottom. So we had to use common denominator and factor to turn our answer into the answer that we would get by traditionally working a problem out. So this problem is like taking from calculus, and a lot of times in calculus problems, when you have to factor, you have to do tricks like putting in multiplying by 1 and writing a number over itself to get fractions out, factoring out the smallest exponent, which turns out to be a negative number, and then we get the answer. But to get the calculator to show the same answer, we have to go over to here, and we had to use common denominator, and then we had to use factor. So again, turning our calculator answer into our traditional answer took a little bit of work. let's go ahead and take a look at the next page and some of the screenshots. So they show us here when they did this with the factor command, turning out to be this answer. Then they show us using the common denominator, okay, with this particular one, but not using the last factor. So I went ahead and used factor twice, because once I got the answer with the common denominator, then the factor could do some good for us. So again, you have to sometimes manipulate this stuff, or you have to do a hybrid where you get an answer and you can see you can factor out the 4, so you can see that your traditional mechanical way of doing the problem is the same as the calculator way of doing the problem. The next thing we're going to look at is factoring by grouping. So when we have a polynomial with 4 terms, we may be able to put the first 2 terms and the last 2 terms together, and then just factor out of the first 2 terms the 2x squared, and factor out of the second 2 terms 3. Then what happens is the next factor is has terms in it, and they both have x minus 1 in each one of these factors. So then we can pull out the x minus 1 and have the 2x squared plus 3. We like to use this technique on trinomials. So if the trinomial doesn't have a 1 and we have 9x squared minus 15x plus 4. In a minute we're going to look at special case problems where when we see 9 and 4, it's very likely that this is a special case. But as you're going to see in a minute, this does not turn out to be a special case problem. So we use the same technique that we used before, except when we get down to this step, we have to use factor by grouping. We make it more complex so that we can group it so we can get the answer. So again, let's take a look. This is positive. So 9 times 4, absolute value is 36. We got 1 in 36. 2 times 18 makes 36. 3 times 12 makes 36. 4 times 9 makes 36. And 6 times 6. Since the last term is greater than 0, we want to add these together. So the first 2 make 37, 20, 15, 13, and 12. Well, again, in the middle we have 15. And since it's less than 0, okay, here we're going to want to make them both negative, so it's negative 3 and negative 12. Then when we factor the first 2, we factor out 3x. And when we factor the second 2, we have to end up with the same answer in both, so that lets us know that the second part has to be the same as the first part, which is 3x minus 1, so therefore this has to be minus 4. Then we bring the 3x minus 1 out of both into the back, and we end up with 3x minus 4 times 3x minus 1. Flipping to the next page, we can see this on our calculator. So if we go over here and go back to our home, go back to our current document, and go to the next example, we see this done with our calculator. So the calculator makes factor by grouping and factor trinomials easy. And here's the screen that's shown on the calculator, and you can see it came up with the same answers that we came up by doing it ourselves. The next thing we want to look at is the special factor formulas. So the special factor formulas have to do with perfect squares, with a positive double the 2's product, and subtract the double the 2's product. So this one turns out to be u plus v times itself, so you can write it with an exponent. And this turns out to be u minus v times itself, so you can write it also with an exponent. So in both these cases, you can write it as squared. If there's no middle term, it turns out to be u plus v times u minus v. And the cubics turn out to be the u minus v cubed is u minus v. The u plus v is u plus v. The trinomial in the inside turns out to be u squared plus uv plus v squared, and turns out to be u squared minus uv plus v squared. So again, these are kind of hard to memorize. Again, the advantage to the CAS model is we can go over to the scratch pad and we can put these into our calculator and it will give us our answers. One of the things that we like to do on tests is if we have trouble like with formulas like this, we like to memorize them before we go into test, and the first thing before we work any problems that have to do with test over this material is write these formulas down so that we get them correct before we forget. So that's a technique that we like to use. Okay, let's turn to the next page. So the next page has us using these formulas. So if we have u squared minus 12x plus 36, 6 times 6 is 36, 1 times 1 is 1. So this is a likely candidate for this particular problem. So we go right down here and write the answer, x, and 36 is 6. Then we multiply the two together here, minus 6x, and double it, and we can see that it works. Instead of writing this out in the long formal form and putting this in, we kind of go to the answer and then use the FOIL technique, or not, and then use this formula to check out to make sure that this is correct. Sometimes when you deal with higher powers, then you have to use things, several of these formulas at the same time. So this one factored into x cubed minus y cubed times x cubed plus y cubed. Then each one of the cubics factored into x minus y times an expression and x plus y times an expression. So again, if we go over to our calculator, and if we put in, okay, the first one, you can see it can do it. And if we put in the cubics, you can see that it can also get us this answer. So when we're just working out ones without trickery with fractions and fractional exponents, our calculator handles this material nicely. This ends our chapter on material on factoring. Thank you.